All right, everybody, here we go. Time for the first section of the soils lab. Now, if you watched you should have watched the last one. When you watched the last one, I said I was going to start with small, but they're still damp over there. So I'm going to let them dry a little bit. We'll start with large, and it'll be just fine. We just have to be clever enough to put it in the right spot in the data table, but I think we are. All right, so what I'm going to do, I can buy myself some space here. So I'm starting with 800 milliliters of water. We're going to dump until all the space is filled. Then we'll see what is left in here. Then we'll know exactly how much pore space there is in between the beads, because we filled all that pore space with water. I'm going to shake it a little bit, try to get a couple air bubbles out of there. All right, I think that's as good as we're going to do. So I filled it right to the top, and we have 400. I'll go 465 left in the tube. So if I started with 800, and there's 465 left in the tube, that means it took 335 milliliters of water to fill it up. So in other words, there is, in the large beads, 335 milliliters of space. That's the empty space in between the beads. Cool? When it's time to calculate porosity, it's going to be the pore space divided by the volume of the material times 100. Easy. That divided by that times 100. You can do it. All right, permeability. Need myself a meter stick. We'll measure the height. I'll pause so you don't have to watch me walk around the room. Okay. Got ourselves a meter stick. Put this right at the bottom of the column. That's how many beads there are. I'm looking at, let's go 78.5. That is the distance that the water is going to have to travel through this thing. 78.5 centimeters. Cool. Next is going to be the time. How much time does it take to drain these? And I'll drain it right into this beaker so that we can do that last experiment, and everything will go great. All right. Stopwatch. All right, what do you think? You ready? This is going to be hard to do a one with. Actually, here's what I'll do. Start and drain. So I got 5.95. I guess we'll just round that to 6 seconds. And I did it until the stream kind of breaks up, which is what I'll do on all three. It's not really waiting for it all to drain. It's just close enough. All right, so permeability. That's going to be an easy one too. It's just a rate. D over D, distance over time. That divided by that will give you an answer as a rate in centimeters per second. You can do it. All right, capillarity. First off, I need volume of pore space. So I got to steal that from the first lab, or the first experiment. VV was 335. All right, we already did that work. Next is, relative to that, how much water is still stuck to those beads? Well, like I said in the previous video, if I chuck it back in here, it's not all going to come back. Because some of it is still in the beads. So I had exactly 800 in that graduated cylinder. Now I have 790. That means 10 is stuck to the beads, is stuck to the surface of the beads. So, I mean, you guys know what something that's wet looks like, right? So little water droplets that are stuck to these beads. Then we'll do that again for the medium and for the small and see which one holds on to more and which one lets the water through faster and which one has more pore space. All right, there you go. These aren't too bad, eh? How long did it take? Again, this lab looks intimidating. Yeah, 6 minutes. We're going to pop right through this thing. Keep it up, folks. You're doing great.